Hi guys, ngayon we're gonna be focusing on simple harmonic motion in undamped free vibration. So we have a simple sample problem here. We have a spring is stretched 3 inch by 5 pounds weight. Let the weight be pulled down 4 inches below E, and then give an upward velocity of 8 feet per second. So describe the motion. So right now, as what you can observe, we don't have a spring constant. So we're gonna be finding for the spring constant. So we're gonna use the solution, or the formula, Fs is equals to Kx. So our Fs is the static friction force. That would be the W here, which is 5 pounds. So we have 5 is equal to Rk is what we're finding, so this would be K, and then we have we have the X, which is 3 inches. So as what you can observe, the given is in feet, so we're gonna convert it into feet. Since 1 feet is equal to 12 inches, so we have 1/4 of a feet here for our X, so we have K 1/4. So in order to solve for K, we're gonna multiply each side or both sides by 4. So right now we have 5 times 4 is 20 is equal to K. So for our K, we have 20. So since it is K, I'm gonna erase that. K is equals to 20. Since it is a spring constant, so this must be our spring constant. So now we are asked to describe the motion. So we're gonna solve for the motion. Here we have, in order to get in order to describe the motion, we're gonna use the undamped free vibration formula, which is the mx x double dot or double prime plus kx is equal to 0. So for our m, we have 5 as what the given a while ago, and then we have x 5x plus 20x is equal to 0. So for we have 5 pounds here, and because it is it pulled the spring downward, so there is a acceleration in the based on there is a gravitational force. So for our m, we have 5 here, and then there is a acceleration due to gravity that was acting on the static friction force. So the value for acceleration due to gravity is 32. So we're gonna eliminate the denominator, which is 32, so multiply both sides by 32, so this would cancel, so we are left with 5x double dot plus 20 times 32 is 640. X is equal to 0. So right now we have the coefficient here, so we're gonna divide both terms by 5. So we're left with x double dot plus 640 divided 5 is 128. X is equal to 0. Now we're gonna make it an auxiliary. So we have the, since it is in double prime, so it would be m squared plus 128, since this is just x, so it would gonna be vanish. So we are left with 128 is equal to 0. So right now we have to find the m. So square them in order to solve for the m. So we have squared, so m squared, so that will gonna cancel, so m is equal to square root of 128 is 11.3, so this will be positive negative 11.3. so we already have the m. So in order to find the x in terms of time, so x t is equal to, we have c sub 1 cosine of rm is 11.3 t plus we have c sub 2 sine 11.3 t. So we're gonna find for velocity in order to describe the motion of the spring. So v t is equal to, we're just gonna derive these terms. So we have derivative of 11, derivative of, now for the derivative of c sub 1 cosine 11.3 t, it would be negative 11.3 c sub 1 cosine of 11, it should be sine. So we have sine 11.3 t plus derivative of c sub 2 sine 11.3 t is 11.3 c sub 2 cosine of 11.3 t. So now we already have both equation, the x and the v. So right now we're gonna solve for the value of c sub 1 and c sub 2. So we have the condition at time is equal to 0, rx is 1/3. So based on the given, so we're just gonna substitute it in this equation. So we're just gonna substitute it here. So we have 1/3 that was x, so is equal to, we have cosine 1, so cosine c sub 1 cosine of 11.3 t. So since t is equals to 0, so we're gonna substitute the 0 here. So this would be cancel, left with 1. So we have c1 is equal to 1/3 or 0.33. So for our c2, we're gonna have the condition t is equal to 0, and then the v, which is the velocity, is in negative 8. So, we have negative 8 is equal to 11.3 C sub 2. So, we're gonna substitute it here. So, C sub 2, since time is equal to 0, so this would be 0 here. So, we're gonna cancel. We're left with this 11.3 C sub 2. So, we have to eliminate this 11.3. So, we're gonna divide them by 11.3. So, we are left with C sub 2 is equal to, we have negative 8 over 11.3, or 0.71. So, in order to determine or to describe the motion, we're gonna have to substitute the C sub 2 and C sub 1 in this equation. So, we have the xt, or x in terms of time, is equal to, our C sub 1 is 0.33. So, 0.33 cosine 11.3t plus, this should be minus, since our C sub 2 is negative. So, we have minus 0.71 sine 11.3 t. So, this would be our description for the motion of the spring.